Imagine if all jobs were taken over by AI. Many people find it scary or negative, but what if it could actually help us make our lives easier or reveal things people tend to miss? And it also could help us prevent fish from dying from stress. A lot of aquaculture farms tend to lose a lot of their income because of this, and actually, more than 3 billion people rely on fish as a major source of protein, so we simply can't ignore this problem. And I'm Anne, and I'm gonna show you how I used AI to help solve this problem. What you see now is a video of swimming fish, but do you really think observing them in such videos is easy? Even experts have to spend hours and days analyzing such videos to spot small behavioral changes that often go unnoticed. You might still be wondering what those changes are. Let me tell you. First of all, color. Stressed fish often shift their color from darker to paler or vice versa. It depends on species. Then, breathing. Rapid motion or repeated trips on the surface may indicate that something isn't right. And appetite. Often fish changes their body mode from grow and digest to stay alert. And behavior also matters. Some fish become territorial, fighting, chasing, biting, and some just hide. And finally, movement. Frantic motion, rubbing against objects, or hovering in places may all reveal that something is wrong. And what you see on your screens right now is my model detecting salmon and visualizing their swimming patterns. Well, of course, anyone can see a fish on the screen, but my model is useful because it tracks how the fish move and helps predict stress at early stages. So, how did I create this model and how could you create one too? Well, I started from the most important step, collecting and labeling a dataset. And it was quite a challenge actually because there aren't many available open or free sources online, especially since I focus on salmon. But I managed to collect more than 100 examples, just enough to get started. I also did labeling using an app called Spot. It's a tool for creating labels for almost any computer vision models, including YOLO. I manually drew a bounding box around each salmon in every photo and downloaded the label data the app generated. However, 100 examples were still not enough, so I used a technique called augmentation. In my code, it slightly changes each photo, adjusting lighting, rotation, or color to make the dataset more diverse and help the model learn better. You can see that it only takes a few extra lines of code, but it's super helpful. Here are some examples. This is a batch, a set of photos that my model proceeded at once. You can notice that some images have unusual lighting or rotation, and that's all thanks to augmentation. I used parameters like degrees, translate, scale, shear, flipute, mosaic, mix-up, and so on. The parameters HCV_HCV adjust hue, saturation, and brightness, helping the model adapt to different lighting conditions. Then degrees randomly rotates the object, translate randomly shifts the objects within the frame, scale changes their size, and flipute or flip randomly flip the object vertically or horizontally. And Mosaic combines four images into one, helping the model adjust to detecting less noticeable or smaller objects, while Mixup combines two images into one, teaching the model to deal with noisy or overlapping visuals. The key difference is that Mosaic doesn't change any visuals like shape or color, while Mixup changes how those images look. Then I trained a computer vision algorithm called YOLO, which is short for You Only Look Once. And it took a lot of time because model has to train on a diverse dataset and process many examples. Here's what the output shows, more than 7 hours for just 15 epochs. This is a training process. It displays the current epoch and values like box loss, class loss, and DFL loss. And in this graph, you can see the final results. So, what are these values and how can they help? Well, first of all, box loss. It represents how well the model draws the bounding boxes around the objects. Then, class loss. It shows how accurately the model classifies those objects. Then, third, GFL loss. It helps the model put those bounding boxes more precisely. And epochs is a full round of the model training on the whole dataset. And understanding these values is really important because if you train the model onto few epochs, it will be not trained enough, and if you train it onto many epochs, it will be overtrained. Moreover, understanding everything only by graph is really convenient because you don't have to run any tests. You've already seen my model detecting salmon in photos, but let me show you again. So After this part, I moved on to a more challenging one, making it detect salmon in videos and draw their swimming patterns. I used OpenCV for that. It didn't just make the lines between every center of bounding boxes, but it also tried to recognize which fish was the same one, even if the bounding box slightly changed or disappeared for a second. It used color and position for that. As I already mentioned, I had some problems with finding appropriate photos for the dataset, and I had the same problems with videos. I didn't have any high quality videos of salmon, so if you looked carefully enough, you could notice that it's not a salmon but kinda similar fish. And I'm actually working on that. I mailed a few people who could give me an access to some of their salmon videos, but I'm actually not sure if they'll reply because they weren't active in the social media for over a year. And another potential problem could be in labeling the dataset. As I was doing it completely on my own, it might not be as perfect as possible, so it can affect how precise my model is. And speaking of the improvements, there are several next steps for this project. First of all, I want to expand it beyond salmon. The goal for the model is to detect and distinguish not just salmon, but several species. Then, as I've already mentioned, dataset actually matters. So the key improvement would be to expand it and make more diverse. And finally, I want this model not just to draw the swimming patterns, but actually predict stress and tell us when the fish is stressed. And that's all. Thanks for watching. I hope you enjoyed it. And if you want to learn more about my project, you can check out my article. The link is in the description. Bye.